Question is very simple. A is a set of all complex number which are looking like this. Theta is your real number. Now they are telling you A contains exactly one positive integer n, and you need to find what is n. So what do we do? First of all, if it is a positive integer, so it is a real number, of course. That means imaginary part is 0. That means if it looks like x plus iy, then your y has to be 0. Now what do we do? Does this number looks like this? No. If you want it to look like that, what do? You multiply by the conjugate of the denominator in numerator as well as denominator. So let's do that. Now multiplying denominator is simple because easy numbers are involved. So let's do that. 7 is 49. So minus 9 I square is negative 1. So you get plus 9 and then you write cos square theta. That's what you get. Now, in the numerator, let's try separating the real and imaginary parts because we understood, right? Imaginary parts, we have to equate it to 0. So, what's the real part here? Now, do you see real part you will get when you multiply this guy with this guy and also this guy with this guy. So, let's write what you get. So, you get 1967. So, numbers are huge, so let's not multiply them. So, this plus, okay, so I square is a negative 1. Okay, so I am writing negative 1686 times 3, and then you write sine theta cos theta. This is your real part. Now imaginary part we already taken I out here from here, and then write the rest of the part. How do you get that? So you multiply this with this, right? How much do you get if you multiply this guy with this guy? So you end up in getting 1967 times 3 cos theta. What else? How do you get the other one? When you multiply these two guys, okay? And you get 1686 times 7 into sine theta. Now you want it to be purely real. That means you don't want your imaginary part. You want your imaginary part to be 0. So let's equate this to 0. Now you can solve this at your own convenience. What we see is relatively big numbers are involved. We start picking out this 3 outside. Okay, if my 3 is outside, so from here, is this divisible by 3? Let's check that. So you get 5, 6 and 2. Yes, it is. Okay, now let's push the 7 outside. For pushing that out, let's see if this is divisible by 7. The answer is again yes. You get 2, 8 and 1. Okay, so you are left with 281 cos theta, this. And there is a good news, right? Because you can clearly see that this multiplied by 2 gives you this. So very simple. Okay, what you end up in getting is cos theta plus 2 sine theta is 0. And from here you end up in getting your tan theta is negative half. So for this value of theta, you get this number to be purely real. So, but sine and cos are involved. So let's try finding using the triangle. This is root 5. So for this value, you get two solutions. One is sine theta is negative 1 over root 5. Cos theta would be 2 over root 5. You can use this triangle to get all these values. Or you can have sine theta is 1 over root 5, that is positive, and cos theta is negative, minus 2 over root 5. Now, if I want to see what kind of integer, because that is what you want to find out. Okay, for that, I need this to be an integer now for these values of theta. So let's try writing that value here. Now we have already seen 281 is multiple of both of them. So we clearly take 281 common. You get 7 times 7 minus 281 6 times you get this number into 3. Now you need product of sine theta cos theta. In both the cases, they are the same, that is negative 2 over 5. So we write negative 2 over 5. And denominator value 49 plus 9. Since you have squared the cos, it is again the same for both of them, that is 4 over 5. So you write 4 over 5. Now let's see if we are getting an integer. So here we end up in getting 49 and plus 18 times 2, that's 36 over 5. And lucky enough, in the denominator also you are getting the same thing. So you get these two things cancelled and you end up in getting an integer which is 281. So the value of n in this question is 281. See you with another question soon. Bye bye.